Student, uh, Precalculus Chapter 2, Section 3. Polynomial. We're going to divide polynomials. There are two methods for dividing: long division and synthetic division. First, we're going to talk about long division of polynomial. Long division is the same as factoring out. Okay, so if I can factor out, that means I can divide. Same things. Like if we, as this is here, we have this function. Okay. It happened when x equal 2. So f x2 will be 0. If we plug it here to everywhere, the answer is going to be 0. And because this is equals 0 at x equal 2, then I can divide the entire polynomial or equation by x minus 2. By x minus 2. We'll see later on why did I use x minus 2. Because if I set this equal to 0 as a solution, then x is going to be equal to, like in here. Now, after you divide by x minus 2, the answer is going to be a new polynomial with lower degree, because the highest degree here is 3, then the answer should be the highest degree is 2. Okay, your final answer should look like this: fx equal x minus 2 multiplied by qx. What is the qx? That's the result of dividing. That's the result of dividing. Okay, let's go and work in this example. We're gonna do this step by step to divide. Let's see where we have. Okay, we have a room here. Okay, it's the same thing you do dividing numbers, same way. First, we're going to, the question is divide this fx by x minus 2. So what you're going to do, you're going to have kind of like this kind of shape. You put outside x minus 2, and inside you write the entire polynomial: 6x cubed minus 19x squared plus 16x minus 4. Okay. What we're going to do now, we need to think by a formula or a number. If I multiply this x here, I can get 6x cubed. So what is that number? To multiply this x, I get 6x cubed. How about 6x squared? So 6x squared, now I need to multiply it by entire parentheses, not only by x. And that will give me 6x cubed minus 12x squared, because what we distribute to inside. Now copy this exactly under here. 6x cubed minus 12x squared. Now the tricky part right now, we're going to subtract the bottom from the top. Okay, so if I say parentheses here negative, I remember this negative should be distributed to the 6 and the 12. So what make this become negative and this become positive? So 6 minus 6 is 0. Now negative 19 plus 12, how much is that? You're going to get negative 7x squared. Again, we are subtracting. This has become negative 6x plus the 6x, will get 0. This becomes positive 12 minus 19, that's negatives. Now move everything down, whatever left, plus 16x minus 4. We have to repeat this. Now the answer, 6x squared, I should put it here. So qx is going to be in here. That's the result. 6qx is going to be 6x squared. That's the first one. Now you need to think, if I multiply this x here again, I get negative 7x squared. That's basically negative 7x. Multiply by x minus 2, same thing. You get negative 7x squared, positive 14x. You get positive. Now you put the answer over here, negative 7x. And you put the rest under here, whatever the result of multiplication, negative 7x squared plus 14x. Now again, we're going to subtract the bottom from the top. Now this has become positive. Negative 7, positive 7 is 0. This has become negative here. 16 minus 14 is 2x. Brings the 4 down, negative 4. Same thing. What is the number if I multiply this x? I get 2x. Seem only 2. So if I say here 2 multiplied by x minus 2, you're going to give me 2x minus 4. So this 2 here, we'll put it on top, positive. And 2x minus 4, we'll put it here. Then subtract again. Now 2 minus 2 is 0. Negative 4 plus 4 is also 0. That's nice. Well, let's go ahead and say right now, this last number is telling me no remainder of the dividing. No remainder of dividing. When we have no remainder, most likely we have 0 for that function. We'll have zeros, may, or we'll have zeros. Well, let's write the function again. Fx equal x minus 2, that's the result of the one they gave us. X minus 2 multiplied by a qx. Well, what is a qx? We already found it out. 6x squared minus 7x plus 2. Can we factor out the second order equation over here? Let's try that. Let's say 6 times 2, that's equal 12. Then I need x minus 2, parentheses here, parentheses here. Two number, if I add them, -7, multiplies them as 12. Is that, we put x here and we have, because we have 6 in here, I have to put 6 in here. Don't forget that 6. Okay. Those numbers seem like -4 and -3. Okay. Well, with this method, you have to factor out any number and get rid of it because this is an intermediate step. This is not the final step. So x minus 2, I'm going to factor out the 2 from here. I get 3x minus 2. Then factor out also the 3 from here. You get 2x minus 1. So whatever number I factor out, you don't even have to write them down because they are extra. So we factor out the 2, we factor out the 3, and that's it. That's your final answer. Well, if I ask you what are the zeros, you say fx equals 0, then each term here must be 0. So let's use that space somehow. So we're going to say x minus 2 equals 0. That means x equal 2. Then the first 0 is 2 comma 0. Then the next one you say 3x minus 2 equals 0. That one here. And from here, x is equal 2 over 3. That means the 0 is 2 over 3 comma 0. Last one is 2x minus 1, this one here. Because any term equals 0, that will lead the answer correctly. X equal 1 over 2. By moving the 1 to the other side, divide both sides by 2, we get half. What are the zeros? We'll write them down here. Zeros are 2 comma 0, 2 over 3 comma 0, and half comma 0. That's all our zeros. I write it down here, but still the 0 is half comma 0. That's it. We did the dividing. We have no remainder. Then we know we have a 0. Write the function. Then analyze the qx to 2 separate factors. Factor out any number, get rid of it. Then set to 0. We got the zeros. Guys, that's what you do in a test. You follow this process, you have no issue. It's very easy. That the example was the same example. That's the same thing we did. And here immediately, that's that's what we got exactly. Okay. This is a simple example. We can do it quick. Say divide x square. I don't know why they should write fx in here. I don't know why. Fx equal divided by x plus 1. So we have your L shape like that. You put outside the x plus 1 and the entire function under here. And the qx will be here. That's the answer. Now, what we're going to do, we have to think, I need to multiply this x by something, I get x squared. Well, that's only x, so I put x in here. So x times x is x squared. X times 1 is x. So again, where does this x squared plus x come from? By multiplying x times x, x times 1. Now you subtract negative x squared minus x squared is 0. 3x minus, because this become negative, 3x minus 1, you get 2. You get positive 2. Bring down the 5, you get 2x plus 5. Now I need to think, multiply this x by a number to get the 2x. Well, that's the only thing is the 2. So we say here plus 2. Now 2 times x is 2x. 2 times 1 is 2. Now again, you subtract, put negative here. 2 minus 2 is 0. Then 5, this is become also negative. 5 minus 2 is positive 3. Minus 5 minus 2. Oh, this is not 0 like last time. So because this is not 0, that is a remainder of dividing. Remainder of dividing. When you have a remainder, that means no zeros. Like before, no zeros. You have a remainder, no zeros. Well, let's talk about remainder theory here. Remainder theory. Well, as I said, because I'm dividing by x plus 1, if I say x plus 1 equals 0, that will lead to x equal negative 1. Plug in back into this function and say if negative 1, and see what happened. You have negative 1 square. I'm plugging in here. Okay. Then plus 3 multiplied by negative 1 plus 5. Where does this negative 1 come from? Again, from the dividing term. We set it to 0. X plus 1 equals 0. We got negative 1. Now, if we calculate, always remember, negative, when you put a square, it becomes positive 1 minus 3, because negative multiplied by 3, plus 5. So negative 3 plus 1 give you negative 2 plus 5, and that's equal 3. Well, this number, same as a remainder. Same. That's the beauty of it. So this way, you double check your answer. If you have a remainder, go back and plug in the actual initial number. You got it from x plus 1 equals 0. If you match this, then you say you know you did it right. So that's a remainder theory. That's the process of it. Well, let me see. How do you write the final answer? I didn't do that yet for this one. The way you write the final answer, you say it is fx equal the dividing term x plus 1 x plus 1 multiply by qx plus remainder. It's plus 1 here. Remainder. Okay, plus the remainder. So as is always true, then the answer for that problem we have that x plus 1 multiplied by the answer, the qx, x plus 2. What is the remainder? Is 3. That's your final answer for fx. That's the reason if we set it to 0, we cannot get zeros because if there's remainders blocking us. If the remainder is 0, then we can find all zeros. That's the same thing we did. If you have no remainder, this formula work for anyone. Because if you have no remainder, you have no remainder, and you say I can't have a 0. So this is the fx here. That's the way. Just write this. The way I'm showing you, just do it that way. You don't have to write this. It's not important. It doesn't make sense. Just say fx equals this. So kind of like here, they give you global form for the answer, for the way it works of dividing. Your function fx, it will be looking like this. You have dx, that's the thing we are dividing by, that's the divisor. That is the answer of the dividing. They call it quotient, but I'm going to call it the answer of dividing is more clear. That's what you're dividing by. That is your answer. And here you add the remainder. Okay, the remainder. If the remainder is 0, then that's fine. Synthetic division. So synthetic division, that's another way to divide. And let's look at this problem. Here is an example. We'll go directly to the example, the way we do it. In synthetic division, like we have this function, fx equal divide by x plus 3. We do not do x plus 3 in here. We must extract the value of x. We say x plus 3 equal 0. Equals 0. Then from here we say x negative 3. What happened, like if you plug x negative 3 in this function, you're going to get 0. So we need the value of x. Do not use x plus 3. Okay. Then we're going to do this kind of like a table. Make it kind of symmetric. What do you do on top here? you put the coefficient of the x. You have here 1, -10, and -2, and we use the fourth too. One issue in here that I have to power 4, I have to power 2. Where is the power 3? When we do dividing for long or synthetic for missing terms, put 0. For missing terms, put 0. For both type. See, the previous example, we didn't have anything missing, was everything lined up. But if we have missing x square, we put 0x square instead. Okay, here we must put 0 in the formula. Where is it? 0x cube. We have to put 0x cube. Then when we write our coefficient, I have to put them in here. 1. The next one is 0. Don't forget that one is 0. Then -2. Or -10. We skipped. Then the 10. Then the -2. Then you put the 4. So you have five numbers. 1, 2, 3, 4, and 5. Okay. Now, what do we do with this -3? In the book, they put it on top. I like to put it all the way on the bottom. I'll tell you why. You put it here outside. First step, well, let's do this different color. In the first step, you bring the 1 all the way down. You put 1 in here. Then you multiply -3 times 1. So you multiply those two numbers. 3 multiplied by 1. The answer, I put it here, -3. Okay? So -3 multiplied by 1, I get answer -3. Now add those two numbers. Add. Not subtract, add, and put the answer right here. Gonna be -3. We're gonna repeat, multiply -3 by -3. -3 times -3, you're gonna get +9. Again, add those two numbers. -10 plus 9, that's -1. We put the answer down here, -1. After we add the answer all the way in the bottom, you guessed it, you also multiply -3 by -1. -3 times -1, that's going to give me a +3. Now add. Seem like every time you add, not subtract. In the previous long division is subtracting. Here we are adding. That's going to give you the answer is +1. Again, you multiply -3 multiply by 1, you're going to get -3. You guessed it, add. And the answer all the way down here, 4 minus 3 is 1. Well, again, the last one is a remainder of dividing. We have no zeros. If it's 0, then we have a 0. So here we don't have a 0. Now, where is the answer? Where is the QX? A QX, what's the highest power here? It was 4, right? If the highest power is 4, then the answer highest power would be 3. So these are the coefficient 1, -3, -1 are and +1. They are the coefficient of the answer. Okay, so 1, that means x to power 3. This is the one. Now -3, we go down by power to power 2. Then -1 multiplied by x, -x. Then we have the last number is +1. That is your QX. Okay. Now what is fx? Oh, the same thing we done before. We say that fx is equal x plus 3 multiplied by q of x plus the remainder r. So that means equal x plus 3 multiplied by x cubed minus 3x squared minus x plus 1 plus 1. That's the final answer. Okay. Now, can we verify the remainder theory? What the remainder theory said? We already said x plus 3 equals 0. So at x equal -3, if I plug it in here in this, I must get 1. Let's do that. So if -3 equal -3 to power 4 minus 10, -3 to power 2 minus 2, -3 plus 4. Okay, that's -3. That -3 times -3 is +9. +9, this is +81. Now here, -2 to power 2 is +9. You get -90. Here you said -2, -3 is +6 plus +4. Now 4 plus 6 is 10. 10 plus 81 is 91. So you're going to get 91 minus 90. That's equal +1. Guess what? Same as a remainder. So remainder theory, if we plug in the value of -3, we must get back that answer. Yeah, here's our see. That's the same thing we did, except they put the -3 on top. I like it in here, so I can see it. 3 times 1, 3 times 3, 3 times 1, -1, 3 times 1. So it's easier to follow that way. But still, if you get used to, you understand it now, you can still put it on top. It's no problem. Then you have to say -3 times 1, -3 times -3. I mean, in the next example, I think they're going to simplify it. We already talked about the remainder theory. They give you examples as they verify that the remainder theory So if we do here the dividing at x equal -2, we put the coefficient. Do we have any missing term? Cube, square, x, no missing terms. So we're gonna put 3, 8, 5, -7, all of these numbers. We put them down here and make sure you have x equal. Here they give it immediately, and here we put -2 anywhere you wanna put it. Let's put it here like the way they did it. This is now what we have to do. We move the 3 down, all the way down. We move it down. That's where the 3 come from. Now you multiply -2 by 3, you get -6. You add, you get 2. Now -2 times 2, you get -4. 5 minus 4 is 1. -2 times 1, you get -2. Now -7, -2, you get -9. Okay. So what is the -9? It's a remainder. So what the answer should be in here? Fx equal, because this is x -2, I can convert it to x plus 2. This become x plus 2 multiplied by the qx. What's the qx? What's the highest power? 3. So the answer should be 3x squared plus 2x plus 1 minus 9. So this is the divisor. That's the qx answer of dividing. That is the remainder, minus 9. Remainder theory, f -2 equal 3 -2 cube plus 8 -2 square plus 5 multiplied by -2 minus 7. Now, -2 to power 3 is at -8. -8 multiplied by 3 is as -24. Now here we have -2 to power 2 is 4 times 8 is 32. -2 times 5 is -10. -7. Let's add up. 32 and 24. How much is that? 6 plus, that is 8. 8, -10, and that's -17. -17 take away 8, gonna give you -9. Oh, it is the same. All of these is the same. So if we have a remainder, that's the way we verify we are correct. We'll go quickly over this example. This example, they are asking us to divide 2 consecutive times to verify it is correct. So first we have to divide by x minus 2, then by x plus 3. So to use synthetic, then we have to say x minus 2 equals 0, then x equals 2. The second time we say x plus 3 equals 0, then x equals -3. And all right, so these are the coefficient 2, 7. Do you have anything missing in here? 4, 3, 2. No, nothing missing. All terms available. So we have 2, 7, -4, -27, and 18. We put them in here. 2, 7, -4, -27, -18. Now, first we have to divide by this. We have to put +2 in here. Now, 2 times you bring the 2 down. Then 2 times 2 is 4. You add is 11. 2 times 11, this 2. 2 times 11, 22. You add 18. 2 times 18 is 36. You add as positive 9. 2 times 9 is 18. We got what? 0 remainder. What's that mean? It's a 0 remainder. That means I can divide by x plus 3. Because if not 0, then I'm going to say, that's as far I can go. I cannot divide again. So we're going to take these coefficient here and use them for the next dividing the x minus 3. So we're going to put -3 and move this down and multiply like that. Let's see. All right. So 2, 11, 18, 9. That's what we got from the previous dividing. That's the answer. That's the QX first time. Now move the 2 down. -3 times 2, -6. You add -15. You add -9. You add. Again, we have no remainder. That means the whole entire thing, it will have zeros. And this is the new, let's call it a QX2. QX, 2. That's because we have another QX. But that's what we're going, because we already divided by x plus 3. What is the final answer? Fx. They told us it was x minus 2, x plus 3. Those are the factors. When we divide by them, they are the factors. Now multiply by 2x squared plus 5x plus 3. So that is your final answer after dividing 2 times. We divided 2 times, we got this one. Can I break this to another couple of brackets? I think we can. We do the same thing. 2 times 3 is 6. Then you factor out. Well, let's do it again. That's all right. So if you say 2 times 3, that's going to give you 6. So 2 number, if you add them up, is 5. This number. If you multiply them as 6, well, obviously they are 2 and 3. Right? 2 and 3. So remember, when I am going to make here 2 bracket. It's not 1 x, there are 2 x's. 2 x's. 2 x's, we're going to put what we said. A is going to be, let's say 2, and this is a 3. So we can say plus 2 plus 3. Now we need to factor out any number and get rid of it. So we have the 2 here, we factor it out. So your final answer should be looking like this. We factor out the 2, we get x plus 1. This one, there is no factoring, 2x plus 3. Now, what are the zeros? Question mark. You set each one equals 0, 0, 0, and 0. Then we're going to get here. Well, you said this x equal 2, 2, 0. Now, here x equal -3. Here x equal -1. Here x, when this 0 become 2x equal -3 divided by 2, x become -3 over 2, 0. This is all zeros. Well, I don't know if you like the synthetic or the long division. In the question, if they specified do this type of dividing, you do exactly what they say. If you said, if it didn't say anything, you choose a method you wanted to. Well, let's look at some practice I have so you can do it by yourself. It's extremely important, guys, to practice. Example, we are in chapter 2. Let's look at the section 3 practice. Here we go to example. Do long division for this and do synthetic division. If you want to practice really more, you can do both of them, one time long division, one time synthetic, and you must get the same answer. So long division does not give you different answer from synthetic. Both will give you same answer. And remember, do not forget if there is any missing term, you put 0. Like in here, we have x cubed, x square. What is missing is the x. So you have put 0x. The other one, you have x cubed. We jump to x. So we're missing the term x square. Okay. When you divide, if you use synthetic, you set this equal to 0. And you find the number to use it in the dividing. If they're asking, do the remainder theory, just plug it in the function and you get the answer. All right, we'll stop here.